Welcome to everybody to my YouTube channel Mass Insights. In this video we are going to discuss very important topic called how to represent sets by using Venn diagrams. These Venn diagrams are not only useful for 8th class, 9th class, intermediate, and they are very useful to solve the problems in different competitive examinations. Shall we? In the previous videos, we established the relation between any two sets by using different formulas. But in this video, we are going to discuss how to establish relation between two or more sets by using Venn diagrams. Actually, the term Venn diagram, Venn is named after a scientist called John Venn. He is a English logical mathematician. After his name, we named the diagrams as Venn diagrams. See the name itself, VENN, Venn diagrams. In these diagrams, we use rectangle and some circular geometrical figures called circles to represent the sets. You represent the universal set U or mu with the rectangle and all the remaining sets by using circles. You know that the universal set U is superior set, that means bigger set to any other sets. All sets are subsets to universal set. So we will represent all the sets within rectangle by using circles. Whatever the elements of a particular set, we will write those elements in those circles and we will represent. You should not write the circles outside the rectangle. Why? Because they are subsets to the universal set. Whatever the elements they have, all the elements of that should be in the universal set. For example, I will explain by taking an example. See, this is a rectangle. I am representing the universal set with rectangle. You have to write like this. So whatever these sets you are going to write, those should be in this rectangle only. Why? Because they are part of the universal set. So suppose if I take A is equals to 1, 2, 3, this should be written in this only, and you have to write its element here only. Why? Because this universal set is superior set on all the elements of A or within the universal set. If you write like this, that will not correct. Why? Because some portion of the set A is outside the universal set, and hence the set A is not subset. The definition of subset says that if every element of a particular set or in the second set, then the first set is said to be subset to second set. Otherwise it is not. I will explain, I will clear it with more examples. Suppose if you take set of odd numbers are 1, 3, 5, 7, 9, 11 and so on. See, all these numbers are in the set of natural numbers. So natural numbers contain all the odd numbers. Therefore these odd numbers are subset to set of natural numbers, and that natural number is called universal set. Similarly, if you take rational numbers and irrational numbers, and all these rational and irrational are in the set called real numbers. Every rational number, every irrational number is in the set of real numbers. That's why the set of real numbers is said to be universal set, and the set of whatever the rational numbers, irrational numbers are all subsets to real numbers. If you want, you may represent by using this rectangle. See, this is set of real numbers, and you have two rational numbers. Rational numbers are represented with q, and irrational numbers with q dash. See, rational numbers, so whatever it may be, 1 by 2, 1 by 4 and root 2, pi, e, are all in the set of irrational numbers. That's why I am writing all the elements within this circle and rational numbers within this circle, and these two circles should be within the rectangle. Why? Because these are subsets to universal set real numbers. In this way we may establish the relation between any sets. By using Venn diagrams, we may establish relation among the sets and some operations on sets also. The first operation on sets is union of two sets. You know that union of two sets is a new set which contains the elements of A or B or both, but that is by using a formula. Now, how to establish that A union B by using Venn diagram? See, I am taking the first one, A union B. If A intersection B is not equals to pi, that means there should be some elements which are common to both A and B. That's why I am writing that A intersection B is not empty set. How we will represent this A union B by using Venn diagrams? You know very well, for every universal set you have to draw the rectangle. Within that, whatever the number of sets we are going to establish the relation, you have to draw them within the rectangle and name them as A and B. For A, you may represent a particular type of lines, whether they may be horizontal or vertical or cross line also. See, I have only two sets, that's why I am using horizontal and vertical lines. See, the set A is represented as horizontal lines, so you have to draw the horizontal lines throughout the circle A, and also the set B is represented with vertical lines. You have to draw the vertical lines throughout the circle B, and A union B is the area where it contains only the elements of A, only the elements of B and the elements of both A and B. You have to show the area. See, if you observe these horizontal lines, only this area represents only A, and this area represents only B, and they are meeting at one particular place. That is the area where the elements of A and B meet. That means the common area of A and B. So if you want to say the A union B area, you have to say that the area where only horizontal lines are there, only vertical lines are there, and the area where they are meeting, where they are having common area also. You have to write by putting plus between the areas. If anybody asks you what is the area which represents A union B in this, you have to say the total. So this is when A intersection B is not equals to a particular empty set, means they have some elements which are common. Coming to second, in this case A union B, this is the representation of A union B when A intersection B is pi. That means there are no elements which are common to both A and B. That's why I didn't intersecting the circles. Why? Because A and B are quite different. They don't have at least a single element common in them. That's why this is different, this is different. That's why I am representing A with horizontal lines as usual and B with vertical lines. Now the area which shows A union B is nothing but the set of horizontal lines plus set of vertical lines. There is no common area. There is no area where these vertical and horizontal lines are meeting. So if you want to say A union B, if A intersection B is equals to pi, that means A and B are disjoint sets. You have to show the Venn diagram like this. Next operation by using Venn diagrams, that is very important. Intersection of two sets. I am taking two sets A and B. Then the area which shows A intersection B by using Venn diagrams. Similarly, as usual in the union of sets, I am representing set A with a circle and drawing with horizontal lines throughout the circle A, and I am taking B with vertical lines. You know, A intersection B is the area where A and B meets. That means the elements which are common to A and B are called A intersection B. Here the vertical and horizontal lines are meeting in this area only. So if you want to show the area which represents A intersection B, you have to show like this. This is the only area, not this and this. Some students are comfortable representing in this way, and some students will write directly where the area which represents A intersection B by shading the area. You may shade this area with color pencils also, which creates interest in you to represent Venn diagrams. In the next video, we will draw more Venn diagrams on union and intersection of two or more sets. And if you like my video, kindly subscribe to my channel and don't forget to press the bell icon. Thank you. We will meet in the next coming video.